Okay, good morning. This is the second video in which I talk about a quantitative variable. This is a problem we did in the Monday, Wednesday class, but since we lost a day on the Tuesday, Thursday class, I thought I would record these because I think they're good examples and it's good for you to see a very thorough explanation about what's going on with these scenarios. So this is a particularly powerful example of how statistical evidence can be used to show bias or show no bias in a situation. So I refer to in this a study from 2016 called Comparing Black and White Drug Offenders, Implications for Racial Disparities in Criminal Justice and Reentry Policy and Programming. In this article or this study, they found that the average sentence for all drug-related offenses was 16 months with a standard deviation of 9.1 months. That asterisk is there because the 9.1 months wasn't provided in that thing, but with everything they provided, that's a good estimate. So it wasn't provided, but assume these accurately measure the population mean and standard deviation. So what that's saying is, you just take all drug offenders and say, put them in, they're all found guilty. The judge comes up with a sentence, and on average for all offenders, 16 months was the average, right? Judges are different, states are different. I don't know how much priors are involved in this, but you'd expect an individual variation. But if you start taking samples, you should just be able to take random samples and get very similar averages when you look at the average offense. So in this particular case, they separated and they said, well, let's just take a sample of every one of the offenders as Black, and they took 62, a sample size of 62. Theoretically, there's no reason to think they should have a significantly different time that they were given. So there's really no reason to think that the average of that sample should be any different than 16. And actually, categorizing by race shouldn't change the sentencing time if there's no racial bias in sentencing. So let's look at what happens. It helps to start just by looking at the distribution in general. Any sample of 62 offenders should average out to be numbers similar to 16. So I'm going to kind of jump down, and the distribution of this is 16 right in the center. And then you'll notice that the numbers defining a standard deviation up and down it looks like about 1.2. I'll show you where that number came from. So it would be a common mistake on problems like these to say just 9.1 is the standard deviation. But remember that let's kind of add in what we see here. So this 16, that is going to be the population mean, and the population standard deviation for individuals is 9.1. By individuals, that means when you look at the differences between every single sentence and the amount of times. But that's going to be different than the standard deviation for a sample of size 62. And it's a pretty simple calculation you do to look at that. If you want to know the standard deviation when you're comparing means, you take the standard deviation for individuals and divide by the square root of n. So that 9.1 we've seen, and we know that the sample is going to be size 62. So this works out to be about 1.1557 da 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 da. Let's just call that about 1.2, which is exactly where we get that 1.2 down here. So what this shows is most of the time we would expect any sample of 62 offenders, if we took all their sentences and averaged them out, they should average to be very close to 16 months. It's possible, quite possible, that it would average out to be something higher, like 17.2. It's possible, but getting weird if it averages out to be 18.4. And further than that, 19.6, we should essentially never see values above 19.6. But if you look at what happened, that sample, when they disaggregated the data into just looking at Black offenders, the average sentences was 20.9 months. So notice that another 1.2, 4 standard deviations above the mean would only get us to 20.8, and our sample mean, which is an X bar, is way, way over there. So that is way out of line, right? So what that means is that you can't even look up z-scores past 3.5 on a table, and this z-score would be over 4. So you could say the probability of this happening is essentially 0. You'll see that those numbers for the right tail get to be almost nothing. Almost no values are expected to be larger, 20.9 or larger. So what that means is, of course, you say, oh, that can't happen. Well, it did happen. This is exactly what happened when they looked at those particular 62 offenders. Their average was off the charts. So what that shows is very strong evidence that there's racial bias in sentencing, and essentially 0% chance that this is only due to sampling variation. So the one other thing I'm just going to add here is just really making sure, if you need to, calculate the z-score. And in general, data minus mean divided by standard deviation. In this case, the data is that 20.9 month sentence on average minus the 16-month population average. And we just found that standard deviation for this distribution to be 1.2, and that equals about 4.22. Over 4. We already found it. You can't even look it up anyway because it's off the charts on our table. And if you plugged it in a StatCrunch, it would be a very, it would be 0.0000 something. Very, very, very unlikely. So this is a good example, and there's more of this coming, of low probabilities are strong evidence. The 0% really means there's a 0% chance that this is strictly due to sampling variation. So there is an example of quantitative variables. This is a particularly upsetting example, but it also has a lot of power in it to show that we do have means statistically to prove instances of this and look and argue for reform. All right. Thank you for listening.